In the early 1990s, a coalition of computing giants set out to build a processor that would leapfrog everything on the market. It was called the PowerPC 620, and for a moment it looked like it might redefine high-end computing. It promised to be the fastest, most advanced chip of its generation. Instead, it arrived late, landed in a market that no longer wanted it, and quietly vanished from history. This is the story of the PowerPC 620, a chip built with real ambition that ultimately became a footnote. The story begins in 1991 when Apple, IBM, and Motorola formed an unusual partnership known as AIM. Their goal was to challenge Intel's dominance by building a new family of processors based on IBM's Power architecture, adapted for a broader range of machines, from desktops to servers. The PowerPC line launched in 1992 with the 601, aimed at everyday Macs and workstations. But the alliance also wanted a flagship, a chip built for the high end of computing, capable of powering servers and workstations that rivaled the best from Intel, DEC, and Sun. That chip became the PowerPC 620. It entered development at a moment often called the CPU wars, when Intel's Pentium Pro was taking shape, DEC's Alpha chips were pushing clock speeds to new extremes, and Sun Spark processors dominated the workstation market. The 620 was IBM and Motorola's answer to all of them at once. What set the 620 apart was that it was a genuine 64-bit processor from the ground up, not a 32-bit design with extensions bolted on. Its registers, data paths, and memory addressing were all built natively for 64 bits, years before 64-bit computing became standard in mainstream machines. The 620 also used out-of-order execution, meaning it could reorder instructions on the fly to keep its internal units busy, rather than stalling on delays. Combined with an aggressive superscalar layout capable of issuing multiple instructions per cycle, the design was, on paper, comparable to or more ambitious than the Pentium Pro and Alpha chips it was meant to compete against. It reflected a belief that the future of computing belonged to wide, deeply pipelined, fully 64-bit processors. Turning that ambition into silicon proved far harder than expected. The 620's complexity pushed the limits of manufacturing technology available at IBM and Motorola's fabs in the mid-1990s. Yields were poor, meaning too many chips coming off the line were defective or undermining. Power consumption and heat output ran higher than planned, a serious problem for a chip meant to compete on efficiency as well as speed. Meanwhile, the three AIM partners did not always agree on priorities. Apple was focused on desktop Macs and increasingly skeptical that it needed a chip this large and power-hungry. IBM wanted a strong server product. Motorola was managing its own roadmap pressures. What began as a unified vision fragmented into partners pulling in different directions, and the chip's timeline slipped repeatedly. By the time the 620 was ready for production around 1995, the landscape it was designed for had shifted. High-end servers and workstations, its intended home, made up a smaller and more specialized slice of the market than expected, dominated by entrenched players with established software ecosystems. Intel, meanwhile, was iterating faster than many expected, and the Pentium Pro and its successors kept closing the performance gap while riding the enormous economies of scale of the x86 world. Apple, the partner that might have championed the 620 in workstations, was pulling back. Its consumer Macs didn't need a chip this large or this hot, and Apple's attention was shifting toward the more modest, efficient PowerPC 604, and later the G3 line for its mainstream machines. Commercially, the 620 faced a set of problems that had little to do with engineering. It was expensive to produce, and its performance per watt made it a hard sell against rivals that ran cooler and cheaper. Server and workstation buyers wanted proven reliability and software support, not an unproven architecture with a bumpy development history. And crucially, the AIM alliance itself no longer had a single, unified customer clamoring for the chip. Apple didn't need it. IBM had its own power server lineup to protect and cross-sell instead. Motorola had limited channels to sell it through. Without a partner fully committed to pushing it into volume production, the 620 shipped in only small numbers, mostly to a handful of IBM systems, before quietly being discontinued. Though the 620 itself faded, its engineering did not disappear. Many of its ideas around 64-bit design and aggressive out-of-order execution informed IBM's Power 3 and later Power 4 processors, which became the foundation of IBM server dominance for years afterward. Some of its architectural lessons also echoed through later PowerPC chips used in Apple's G3, G4, and G5 Macs, even though those chips took different, more efficient paths. Today, the 620 survives mostly in technical retrospectives and among retro hardware enthusiasts who track down its rare development boards and documentation. It's studied less as a product and more as a case study in the gap between architectural ambition and manufacturing reality. The PowerPC 620 stands as a reminder that being technically advanced is not the same as being commercially successful. It was arguably ahead of its era, a fully 64-bit, out-of-order design, built at a time when the market wasn't ready to reward that kind of ambition, and when the partners behind it couldn't stay aligned long enough to see it through. Engineers and historians still return to it, not because it changed computing, but because of what it reveals about timing, coordination, and the narrow margin between a landmark chip and a forgotten one.